Yes, F equals to ma. Now units of force. What are units of force?
Newton.
Newton, sir.
Okay, so 1 Newton equals to what? How to like split this 1 Newton?
So like convert into joules or
No, convert it into like other form, standard form, like 1 kilogram,
kg per meter square.
1 meter per second square. Right, 1 Newton equals to 1 kilogram into 1 meter per second square. Okay, this is for SI units. If I want CGS unit, I think so while studying for work, we discussed this topic, right?
Yes, sir.
Okay, then convert this 1 Newton to CGS unit.
So CGS unit means dynes.
Yes, 1 Newton equals to 10 to power 5 dynes.
sir, is it 5 or -5?
It's 10 to power 5.
Okay. Sir.
Okay. So how we got this one? 1 kilogram, it means 1000 grams. 1 meter means 100 centimeter. So the 10 to power 5 gram centimeter per second square. And this is called dynes. Some other units, which is very important, but you might not be useful, but let's discuss that. Because you already studied something in your school, but I'm giving a little bit extra. Might be helpful for your some exams. Anyone of you are preparing for Olympiad or something?
Sir, I am for NTSC.
NTSC. Good. Because those questions are they are asking in NTSC exam. No, I'm giving the extra because you already are studying everything in the school, then there should be something extra. I'm teaching you same thing. There should be something extra apart from your this normal thing. Okay. Fine. So 1 kilogram force. How to describe this? Our other name is 1 kilogram weight. That is equals to 980 dynes. Or 9800 instead of let's take it as Newton. Newton. Let's take this way. Then 1 gram force or 1 gram weight is 980 dynes. Okay. These are just standard, another standards, kilogram weight, gram weight. Now, if you see, you don't get confused with these names. What is the mean? What is the meaning of this one? 1 kilogram force means 1 kilogram force, which has what mass, which has 1 kg, which is attracted towards Earth. That is 9.8 equals to 1 kilogram force. That means 1 kilogram mass is attracted towards Earth. That is 9.8 Newton. That has 9.8 Newton of force. Then this is lower form, 1 gram force. Okay. Easy, right?
Yes, sir.
Yeah. Let's take some numerical. Okay, let me just get some numerical 1 second. of force which produce an acceleration of. Okay, I'm not writing those things. It's just I'm directly writing acceleration because you know all these things. Acceleration of 5 centimeter per second square in a body of mass 20 grams. Then find out force in Newton. Find out force in Newton. Come on. I'll give you 30 seconds.
So could you repeat the question?
A force produced an acceleration of 5 centimeter per second square in a body of mass 20 grams. Find out the force in newtons. I'll give you only 30 seconds. Your time starts now. Come on. Yes, 10 seconds up.
So is it 10 to the power
Sir, is it 10 to the power
-3
minus
Newton?
3?
Yes. Very good. Still 10 seconds were there. What about this? Okay, by the way, I didn't see like who gave answer. Which 2% gave answer?
Sir, I did. Deepshika.
Oh yeah, Deepshika.
I also got the answer.
Okay. Vivek, right? Okay. What about this? Krishna Pranam, are you there? Pulaske, are you there? Satvik? Okay, your mic, something. Okay, then let's go for next question. I guess everyone can solve this one, right? Don't forget to convert this one into, sorry, 0.05. Is it? Mass as 0.02.
2.
Multiply this. F equals to this one and into this one. So 5 2s are 10. 0.001, I guess so. That means 10 to the power minus 3, yeah. Okay, let's try some other question. A force of 15 Newton acts on a body of mass 5 kg for 2 seconds. What is change in velocity of body? What change in velocity of body? Let's start. Your time starts and now. Come on. Same 30 seconds. I don't think it's require 30 seconds also. Seconds up. 15 up. 20 up. What's happening?
So 3 meters per second square.
Yes.
Yes, sir. 3 meter per second square.
Yeah, sir, 3.
Okay, yes. So you all gave in 30 seconds. Very good. But if I ask you acceleration, rate of change of velocities, then
Didn't get the question, sir.
if I ask you rate of change of velocity,
So then also 3 meter per second square only.
Yes, sir. 3.
Okay.
Yeah, sir. It's so
They're asking my v minus u. Okay. Which is a into t. F equals to ma. Mass is 5 into. Oh no, a we need to find out. This is 15. A is 3. Okay, let's go for next question then. Okay, what do you mean by balance force, by the way? What do you mean by balance force? Yes,
So when an object is at rest, when it doesn't move,
object is at rest, it doesn't move. Like example, am I pushing a wall? It's balance forced.
no, sir.
sir.
If the ball moves, then it's not balance force.
No, I'm pushing a wall.
Sir, wall, sir. Or ball.
Wall.
No, it's not balance force.
No, sir.
Okay, think of it. If there is an unbalanced force, what will happen? If there is a balanced force, what will happen? How can we conclude this is the balanced force? Think and give me clear idea.
If only one force act on it, unless the second force act on it.
Okay, for
Sir,
that,
if it's balanced force, then the object won't move. And if it's unbalanced, the object moves.
okay, yes. And before that, who gave answer for him? I have one question. Both sides we are applying force. This is fulcrum. Both sides we are applying force. Then why this one will move down and this one will not move that much down? What's the reason?
Sir, if we apply equal forces, it will remain like that only.
Let's take F1 here, F2. So both F1 equals to F2 equals to force, same force. Now it will be balanced. That's what you're saying.
I think it should be equal to 0, then it will be balanced.
Equal to 0, that means no force. You are sitting on one side of a seesaw and I'm sitting on the one side of seesaw. So as she gave an example, or as she said, like if there is no motion, it is balance force, or there is no disturbance, there is a balance force. But when I ask the question, I'm pushing the wall, is that a balance force? Think it again and tell me now. I'm pushing wall. Is that a balance force? How to know this? If, as you said, if resultant equals to 0, the wall did not move an inch also, not a centimeter also, right? When the resultant of applied force is equals to 0. I'm pushing the wall, but wall did not move. So he is applying same force towards me. That means my force is cancelled out by his wall's force. Let it be friction force or force on the rest, inertia of rest, whatever case, whatever the condition is. Clear? You got clear idea about this balance force?
Yes, sir.
Yes.
Yeah. So that object does not move. Yes, you're right. We all are right. So object does not move. It is balance force. Okay. So in short, oh, internet gone. Yeah. Can you hear me?
Yeah, sir, we can.
Okay, okay. My internet got disconnected. Wi-Fi. Okay. Now let's see. I'm taking a box. I'm pushing on this side with 4 Newton. I'm pushing on this side. Someone is pushing on this side with 2 Newton. Then where should box move? Left or right? Say in left or right?
Towards the right.
Towards the right. By how much?
By 2 Newton.
Net force is on the right side with 2 Newton. Right? This one clear, right? So
Yes, sir.
let me give you some more questions like that. Let's see. You can give me instant answer. It's not a problem.
So for those kind of questions, you should write that statement. Net force is equal to right side by 2 Newton.
Yeah. Net force by how much and where it will move. Right. R means right side it will move. So where it will move and by how much? With how much force?
Left side 5 Newton.
Yeah. Left side it has, because it has 5 Newton extra. Now if I say this side 6 Newton and somewhat this one 3 Newton, then net force will be
Right side by 9 Newton.
9 Newton. Now in this one, if I add 3 forces, two Newton, this is 4 Newton, and this one let's take as 6 Newton.
It's balanced.
Is it balanced?
Yes, sir.
So where it will move? Right or left?
It will not move. It will stay
Not
in
move.
rest.
Stay.
So net force is 0. It will be at not neither right, neither left. So clear with this balanced force?
Sir, I have one doubt.
Yeah. Ask.
Sir, what if like 3 forces are acting on 3 different sides?
Same manner. If wherever the force more, that direction it will move.
Okay, sir.
Right. Suppose we are pulling from 3 directions, you, me, and someone else. So wherever force is extra, those directions. it will move. Now, let's move to some very important topic: fundamentals of forces. But before that, do you need any explanation about unbalanced force?
No need.
No,
Yeah, mostly everywhere there is an unbalanced force. Because we are moving because of unbalanced force, we are able to move. Right? We are applying more force than friction force, which is behind us, or which is dragging us back. We are applying more force. That's why we are able to move forward. So in short, applied force are more than 0. That is unbalanced force. Now this is so important for fundamentals. weight always downward. Weight is mg. Weight W equals to mg. Always downwards towards the Earth's surface. M is mass of this box. And normal force always perpendicular to the surface. This is a surface and this is Earth's surface, towards the Earth's surface. This too clear? Two forces, normal force and weight. You are saying gravitational force, that is also a weight. Clear these two statements?
Yes, sir.
Okay. So let me ask you
Yes.
one thing. This is an inclined plane. Okay, I'm drawing a box here. So tell me, where will be the normal force?
So 90 degrees on the box.
90 degree from the box. Like this way.
Yes, sir.
Yes, sir.
And what about weight, mg?
So it will
From the
be,
ground.
Like this,
no, sir, straight.
straight to the ground,
Yes, sir.
to the Earth's core, towards the Earth's core. It will be directed towards the Earth. That is mg. Always, whenever you get diagrams this way, so always split the forces, normal and mg. Okay, and remember this one, it will be very, very helpful for your 11th standard also, if you're choosing science stream. Now, let me tie something here. This is wall. I'm tying some box. So as usual, weight mg. Now there is one more force in this. This is what a string. There is a tension in a string. Tension is a force. This is also a force. This force occurs when we are pulling or stretching, or for rope, string, something like chain, something, or else what else? Cable, anything like that. Anything related to string or rope that creates tension from the box. So here T equals to mg. Now let's come back here. Here normal force N equals to mg. I'm equating this. So if this condition comes, that means this is balanced force. Here they both are not balanced. That's why this is sliding. If you observe this one, it's sliding down. It will slide, right? Because N is not equals to mg. It is at some angle. So if I want to make N equals to mg, I need to do something here with cos component, which you don't know right now. So I'm not showing you that. So it should do something here, so that it will be equal to N equals to mg, same form. Clear?
Yes, sir.
In doubt in these three diagrams?
No, sir, no doubt.
Okay. Okay, then let's go with the friction force. So what is friction force? What is friction force?
A force that resists motion.
Resist the motion. Okay, exactly. Which moves in opposite direction of the movement.
Opposing force
Opposing
of
force.
an object.
Yeah, can you tell me why it is opposing? Why that friction force is opposing?
Because when two surfaces come in contact with each other, it creates a friction force.
Okay.
So it
suppose
stops, is like slows down the motion.
yeah, it slows down. And if I take a box here and I'm placing it at some table. So until suppose this box is this table and box, these are not like smooth. So if I show this one here, actually if I go with microscopic view, this portion, it will be like this little bit. It will be not exactly smooth. Same manner, this will be also like that. Table. If I show this microscopic view, it will be not exactly smooth until it is ice. Even ice is slippery, it's not smooth until it is exactly smooth. So this will be creating some friction. This will come inside this gap and like it will create some force to stop, resist. It will resist the motion. So that force we gave as a friction force. If we see molecular level, it is like a small force here, like molecules, they are coming in contact with this one and stopping it here. They're stopping it here. So that creates a friction. So we gave a name as frictional force. So there, what are types of friction, you know? What are type of friction, you know?
So there is rolling
Rolling, sliding,
and sliding.
and there is one more, that is static. Name itself suggests sliding, rolling, and static. So which should be the highest? Static is greater than sliding, which is greater than rolling. Right? Okay. So what is Newton's first law? Who will tell this Newton's first law?
So if a body is moving at a straight line, it is in constant speed unless a force is acting upon it.
Until external force is acting upon it. Okay. So object be in rest and be in motion until some external force is applied. Right? What about others? You all are there?
Yes, sir.
Okay. So this is another name of this Newton's law. First law is law of
Momentum.
inertia. Second law is momentum law.
Okay.
Law of inertia. In that we have inertia of rest, inertia of motion, inertia of direction. Okay. So inertia of rest, name itself. We can get so many things from name. What is inertia of rest? Okay.
So when an object is at rest, it stays in the same way unless an external.
Yes. Yeah. What is inertia actually? What is inertia? Vivek?
So can I?
May I?
Yeah, sure.
So objects resist a change in their state of motion.
No,
Yeah.
I think isn't it like when an object remains unchanged?
Yeah, we can say inertia means resisting something. It has tendency to resist something. If I talk about rest, so it has tendency to oppose the change when it is in rest. So it will oppose, like just now we were talking about wall. So wall has inertia of rest, higher inertia of rest than me. So it is staying there. I'm not able to push it. Even when we're sitting on bus and suddenly applies brake, you know this standard example, right? Famous standard example. So if you apply a brake, so we are moving because we are at rest. Bus, let it be moving. Same way, inertia of motion. If you talk about bus again, and bus is in movement, and suddenly it brakes or it applies change. So again, we will fall due to bus inertia. Because of our inertia, that is, we are inertia at rest. Bus is in inertia of motion, and we change the direction. So in all three examples, we can see that. Even when we are like motion, if we talk about motion, inertia of motion, we see, yeah, when we get down to the running bus, right? We have to move a little bit. We have to run a little bit for like, because we already in motion, the bus was already in motion, so we have to move a little bit with it. We have to run a little bit, otherwise we'll fall down. It's simple. Excuse me. Now, inertia of direction. What do you mean by inertia of direction then?
So the direction doesn't change again unless an external forces.
Yeah, it resists the change in direction. So tendency to resist or to oppose any change. So if I say for inertia of rest, so tendency to oppose any change in its rest position, in its state of rest. If I talk about motion, in its motion. If I talk about direction, same thing in its direction of motion. Right? As we are running in a circular form or any other form. Okay. Now let's talk about momentum. What is momentum? Yeah, what's momentum?
So
So
the
the
product
object
of
is at
mass
motion.
and velocity.
Yeah, product of mass and velocity.
When an object is in motion, it has momentum.
Yeah, an object is in motion, it has momentum. Okay. What about others? They didn't join. They might be busy. Okay. Now, if I say momentum is vector of scalar quantity, yes, Pulatsya, is it scalar or vector? Pulatsya, you there? No?
So shall I?
Yeah, sure.
It is a vector quantity, sir.
Vector quantity because it depends on direction also. P equals to mv, product of scalar and vector is vector. Now, units. SI unit,
So kilogram meter per second.
kilogram meter per second, or Tell me in Newton. How to get in Newton? See, we know 1 Newton equals to 1 kilogram meter per second square. So I have one extra second. So what I'll do, multiply by second, multiply by second. So 1 Newton second.
Is it Newton?
Yes. Is it Newton?
Newton second, yeah.
It is Newton second. Now in CGS form. Get me in CGS form. What do you think it should be?
So gram
Is it-
centimeter per second.
Yes, sir.
Gram centimeter per second. Okay. Or
Dynes per second.
yes. Not per, dyne second. Dyne second. Let's do this question. Which question number? I don't know. You use it, whatever number you're using. A ball of mass 100 grams is moving with the velocity as 15 meter per second. Calculate momentum. I'll give you only 10 seconds. Momentum of ball. Come on. The time starts now. 10 seconds. Come on. 5. 6, 7, 8, 9.
So 1.5
10.
kg meter per second.
Super.
So
Super.
1.5
Super.
kg per meter.
Correct. Yes. Very good. So very good. You gave in 10 seconds. That's great. You didn't use calculator, right? No, no, you cannot, because in 10 seconds you will take typing.
Yes,
sir.
sir.
You cannot do in 10 seconds in calculator also. Until you are calculator freak.
So there's a calculator freak also.
No, I'm naming it. That's it. Okay. What about others? Like they became silent or what? Krishna, Pranav, Pulasya, Satvik. What about these three?
Yes.
I'm not taking attendance. You got an answer?
Yes.
Okay, Newton's second law. Let's end with second law. What is second law?
F is equal to ma.
Yes. F equals to ma. Given definition of it. In second law, in terms of momentum. Excuse me.
Force is equal to mass into acceleration.
Rate of
Oh, rate of change of momentum.
change in momentum. Change of momentum is directly proportional to force. Right. Then on the base of this one, we'll do some numerical in the next class because already you have a next class, I think so. Okay. See you in next class.
Okay, sir. Bye.
Bye, sir.
Bye-bye. Do you have any doubt in this one till now?
No, sir.